All right, welcome back, and now we're going to start talking about trigonometric functions of real angles. Okay, so we're going to start by looking at this example here, this graph, where we have theta, right? So we've got this theta, we've got our line segment here, and so we've got theta prime, and we've drawn out this right triangle where we have r, right, the radius, and that's going to be our hypotenuse. And then we've got the opposite leg and the adjacent leg of our reference triangle. Okay. Now, remember the definition is sine, right? So we have sine theta, and this is going to be theta prime. Okay, or actually let's start with theta. So, and this is equal to what? It's equal to y over r. Okay, and then of course tangent theta is equal to y over x. Okay, and see, notice that when we look at the reference triangle, y over r, right, so this is the y direction, right, over r, so opposite over hypotenuse, right? And then tangent theta, we have what? The length of y, y again, y divided by x. And remember, tangent is opposite over adjacent. Okay? So we know that when we take the sine or tangent of theta, we use these formulas. Right? And we put that in our calculator. Okay? Now for the right triangle, for theta prime, so let's look at theta prime now. Okay, now, since x is in the negative direction, x is going to have a negative sign. Remember, these are going to be positive in the first quadrant, right? And if we look at the sides of the right triangle, we're going to use positive sides. So we would write this as the absolute value of y over r, because r is always positive. And tangent, likewise, would be the absolute value of y over the absolute value of x. So it follows that sine of theta and sine of theta prime are going to be equal, except for possibly a sign difference. So, and the same issue is going to be true for tangent. It's tangent of theta and tangent of theta prime, and also for the other four trigonometric functions. Okay? So in all the cases, the quadrant in which theta lies will determine the sign of the function. Okay? But we've also realized that from our previous discussions that, remember, we know that certain functions are positive here, positive or negative here, positive or negative here, positive or negative here. And so we're going to see the same results. Okay? And I think that's all I want to say. All right. Have a great day.